Thank you, Rashi. Yes. So I'm going to talk a little bit about about our motivation for the announcement that I'm going to make soon. But the idea is, and this is kind of core to the philosophy of Hasura itself, is when GraphQL kind of becomes a part of your infrastructure and GraphQL, the implementation of GraphQL becomes invisible. Um, if you think about the way databases work, right? You don't When you want to read raw data inside files, you don't actually build a SQL server, right? The SQL Server implementation is hidden from us, and that kind of makes SQL fun to use. And so when we thought about GraphQL or RQL, we thought about it in a very similar way, which is how can we get a data access API without having to go through implementation details and just kind of working at a higher level of abstraction, right? And that's kind of been one of our guiding themes and principles to say, how can we make a GraphQL API that is fun to use, it's very featureful, very powerful, but at the same time, the implementation is kind of hidden from us, and we get to work at a higher level of abstraction. And that's kind of what I call, what we call invisible GraphQL. If you think about the way Hasura works, let me just fix my pointer here. If you think about the way Hasura works, right? So yeah, Hasura essentially is a metadata engine, right? And what the metadata engine does is it contains information about what tables you have, what relationships you have, what remote schemas you have, what actions you have, right? How they map together, what the authorization rules on each of these things are. And that kind of allows us to work at a slightly higher level abstraction, which is kind of more relevant to our domain, right? For example, we get to use databases the way we would use them. We get to write APIs the way we would write APIs. And then Hasura kind of helps us do some of the work that's required to get the GraphQL API out. In this sense, Hasura is kind of like infrastructure because it can guarantee predictable performance and scalable and security because it takes declarative configuration and then Hasura handles the runtime itself. Very similar to, for example, if you would have something like Nginx, which would take an nginx.conf. Hasura, whenever you use Hasura, however you use it, what you're essentially doing is you're modifying Hasura's metadata. When you use Hasura's UI, and you use the console, what is actually happening is that the console is making API calls to the Hasura server to modify its metadata. Very similar to if you had a database and you would write SQL statements to say create table. The console is issuing commands to the Hasura server to say, track table or create relationship, which is creating entities inside the metadata. If you're using metadata.yaml and you do an import or an export, it's again a very similar. It's again the exact same thing happening in the background where the metadata configuration is changing. In fact, you can choose not to use the console or metadata.yaml at all. In one of our last community calls, Gavin had presented a TypeScript SDK for being able to configure Hasura, which is being able to configure Hasura entirely in TypeScript, because that TypeScript code then generates metadata, which can then be used with Hasura. This is kind of one of the reasons also why we've always thought of Hasura as a service and not a framework, and which kind of results in a lot of the ways Hasura works, is that Hasura is a service, not a framework. Um, as you kind of use this, you realize, that's great. You get to use, you get GraphQL, and that's nice. But there's still some things that you have to do which are kind of not functional, right? Which are not necessarily relevant to your domain. For example, scaling or high availability or caching or integrating with tracing, right? Or distributed tracing, right? And stuff like that. And then, as Drake has often said, running things is not fun. Building things is fun. In fact, he has a very popular song about it as well. So we started working on something in early this year, and it was a engineering squad spanning, as usual, several time zones. Everybody from Los Angeles to Bangalore to Ho Chi Minh City to Melbourne, and there were many hurdles that we had to cross as we were building this out. There was Lyndon's cat. Lyndon's cat would often occupy his work desk. And just in case you can't notice, I have a zoomed up picture of this, which is Lyndon's cat would look at him upside down as well, which, depending on what Lyndon was doing, caused a little bit of a hurt. We would play Pictionary on Fridays, and then Phil came on and joined us for like 15 minutes and drew a bookshelf while Pictionary. And this is very close to what he drew, although I've taken this image from from a stock image set. This is very, very close to what Phil built, which caused odd people, demoralized us a little bit, but we stuck through it. In fact, Shahid, who's the infrastructure lead and the tech lead behind the work that we've been doing, he sneakily got married. He didn't even tell anybody. He just sneakily got married, and at the very last day, he sent across a Zoom link and said, "Hey, I'm getting married." But all of these things happened, and we kind of persevered through these things. Lots of hard work, lots of alcohol, which I'm guessing everyone should now be kind of using a significant amount of alcohol now. But after all of this, what I'm very, very happy to announce is the launch of Hasura Cloud. Hasura Cloud has I'm going to talk about it, and I'm going to talk about how we've been thinking about some of these hard problems around non-functional things, and what we can make and what we can do and what we have done to make it easier to operate GraphQL server and Hasura introduction. So Hasura Cloud is essentially a completely managed GraphQL engine. You can connect it to your databases, your remote schemas, your actions, your event triggers, right? It's serverless scaling, and so you pay per GB that passes through Hasura. You don't have to worry about servers or instances or configuration or number of concurrent users, number of API calls, any of that. And Hasura kind of handles that for you, scales up and scales down automatically for you, and a bunch of other stuff. What I'm going to do is take you over a few of these things and tell you how. Oops, sorry, just a second. I was just looking at the chat messages. All right. So what I'm going to do is I'm going to talk about what this does. So Hasura Cloud handles operations. So operational availability, things like auto scaling, high availability, caching, query caching, data caching, which is what I'll talk about in a bit. Tracing, monitoring, rate limiting, query capture, and a bunch of stuff that make it easy for you to use in production. I think if you think about auto scaling, right? Hasura scales quite well vertically and horizontally because it's a stateless container. But these thresholds at which you set to auto scale, either vertically scale or horizontally scale, really depends a lot on your workload. For example, people have often asked us, "Hey, should I have a 1 gig 2 core Hasura? Should I have a 4 core 8 gig Hasura? Should I have a 16 core Hasura?" And the answer is always it depends. And the only way of finding things out is by actually trying out your workload and doing a benchmark, right? Hasura itself is is a heavily multi-threaded server, and it exploits a lot of shared memory for optimizations, right? Hasura does not run as a serverless function, right? Hasura is kind of Hasura Cloud will provide a serverless experience to us, but Hasura itself as an instance is extremely multi-threaded and uses a lot of concurrent programming to make sure that optimizations around query caching, optimizations around handling WebSockets, making sure that if the authentication key changes, WebSocket connections with the older authorization tokens are rotated and automatically closed, right? And that is kind of hard to when you think about those characteristics and scaling them automatically. It does become a little bit hard to think about the kind of more mission critical your application becomes. Hasura Cloud though, which is our serverless offering, scales up and out automatically so that you don't have to worry about containers or CPU and RAM or number of concurrent users and stuff like that. The way we like to think about Hasura Cloud is not as if is not like hosted Hasura. Although it's functionally the same as hosted Hasura, it's not like a hosted version of Hasura. Actually, what it's more similar to, and what we would, and that's kind of the vision that we have in mind, is it's kind of like a SaaS offering of your own data, right? Whether that data is coming from databases or remote schemas, or whether you're operating on that data through actions or Hasura's mutations, whatever you're doing, it's kind of like a SaaS offering. And just like a SaaS offering, right, you would expect a SaaS offering to kind of be secure. You would expect a SaaS offering to scale automatically. You would expect a SaaS offering to be compliant to whatever you're to the way that you use it. And that's kind of the goal for us behind in the way that we think about Hasura Cloud. Um, the other one of the other things I want to talk about is caching, um, and caching is basically and caching is very interesting. And when we think about caching with GraphQL, there are two types of caching. There's query caching and there's data caching. So query caching is something Hasura GraphQL engine already has, right? GraphQL query plans are cached because whenever a GraphQL query comes in, Hasura has to decide, whether it's coming in from a single data source or multiple data sources, and decide what to do. The part of that query which is serviced by a database, Hasura kind of takes that part out, does a compilation step internally, adds authorization rules to it, and then sends that to the database as SQL. But Hasura also optimizes the way it talks to the database. Um, uh, uh, Much like a GraphQL server, if you think about persisted queries and you think about allow listed queries and stuff like that, even SQL servers and most database servers like Postgres have this idea of a prepared statement, which is that you don't need to send the SQL query to the database every time. What you can do is you can register that SQL query as a prepared statement. And as long as you have the connection open, right, you can basically prepare the Postgres plan, and Postgres will do a query caching of the SQL query itself. This is again one of those reasons why this data access piece in the middle is very hard to be serverless, because if it was running as a serverless function that was going up and down, it would destroy the connection and then recreate the connection, but then your prepared statements are lost, right? And these are the kind of things that become painful, especially when you're running at a significant load and you have a performance characteristic that you want to meet, right? It becomes hard. And what Hasura does is when Hasura looks at end-to-end query caching, if you think about a GraphQL query that comes in with query variables and session variables, Hasura caches the GraphQL to kind of SQL and GraphQL execution plan inside Hasura itself, and any concurrent requests that use the same query, but different variables and different session variables will use the same query plan. And then Hasura also caches the SQL plan with Postgres and registers that to Postgres. So when you think about how a GraphQL query actually gets executed in production, what's actually happening is that the only thing that Hasura is sending to the database is the only thing that Hasura processes are variables, and Hasura maps them to variables inside the generated query, and that just runs directly on the database. This is one of the reasons why when you hit the query cache, Hasura is very, 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 very fast. But data caching. Data caching is something that we have started solving with Hasura Cloud, and that's something that we get to check out. But data caching is the idea of automatically caching the results of API calls, and not just the plan of how the API call is processed. And when you think about data caching, there are two interesting problems to solve, right? The first problem to solve is what to cache, right? And specifically, I'm talking about application level caching, right? I'm not talking about database caching, which is a little bit different. When you think about caching at the application level, right? Let's say, for example, you build a server and then you use Redis to cache, right? You always hear of like, hey, let's use Redis to cache. What's actually happening there? You're solving when you're writing this API, right? And you're trying to cache this API. You're solving two problems. The first problem is understanding what to cache, and the second problem is understanding how to invalidate the cache. Both of these are hard problems and interesting to automate. So let's first let's take a look at the first problem, which is what to cache. So let's say we have an API, and again, this is not very specific to GraphQL. It can actually work for anything. But imagine that we have an API endpoint that's kind of like a /restaurants endpoint, which is kind of like a GraphQL query where you're fetching query restaurants, ID name, menu items, right? Whatever. There's a GraphQL query or an API essentially, and depending on who makes the API call, they would get different results, right? Let's say, for example, user ID1 made the API call. What you really have to do as an API developer is that you have to say, well, who's user ID1? What city are they in? User ID1 is in San Francisco. That's cool. Let's get the San Francisco result. Where's user ID2? User ID2 is in Dublin. Let's get the Dublin result. User ID3 is in San Francisco as well. Well, let's get the cached San Francisco results, right? And so kind of automatically caching this is hard Because if you have something like let's say, for example, you have something like a Cloudflare or an API gateway, it doesn't have enough information to know who these people are, to understand how they will fetch the data, right? To know whether those API results will be the same or not. So even if you had a really good cache, understanding what to cache is a big problem. Interestingly, Hasura does have this information. Because of the authorization rules, Hasura knows for each API call, depending on the end user that's making the API call, who is trying to access what data, and whether for different people, they will end up with the same data set or they'll end up with a different data set. And this kind of helps Hasura solve the problem of what to cache. The second problem is understanding how to invalidate or refresh the cache, right? So if you think about, if you think about the list of San Francisco restaurants that we have that are cached, right? There could be two ways to update this cache. One is that you just cache it for 60 seconds. We know that our app is in San Francisco, and it's concentrated in cities, say, and we know that most people at 2 p.m. will start loading this restaurant list because they're all hungry and they all want lunch.
My mic is making a lot of noises.
Oops, sorry. Uh, I think my mic might be really loud. Let me just check if the audio is if the audio is not clear, please let me know on chat. All right. So if you think about this problem uh, of hot queries, right? Queries that are coming in frequently. You need to cache the results. And one option is that you can cache based on time, which is to say, I know that these queries will come in very frequently at a particular time. And so for a small time window, we'll cache it for a particular time interval. And that's okay because we're okay with serving stale data for these hot queries. And this is you will and this is the most common way that people implement application level caching, because the other side, the other part of the diagram that I have, which is the number two side of the diagram, this is possibly one of the hardest problems in computer science. Right? I mean, well-known. I won't call it joke, but perhaps well-known quip, which is two hard problems in computer science. First, cache invalidation. Second, naming things. Third, off by one errors. So that's a good quip. But cache invalidation is a pretty seriously hard problem, because the other way to solve cache invalidation is to make sure that whenever there are writes that are happening, you are able to take those writes and those events and use that to invalidate the cache. This is something that is possible to do, but is actually quite painful in practice because it's a combination of several things. If you think about it, if the database equivalent of this problem is also called the materialized view update problem, right? You want to keep materialized views up to date dynamically, which has been something that databases have actually not solved themselves, because it's quite complicated to understand how to take an event and determine what cache to bust, right? Um, there's been some recent work that's making this possible, but that's good, and that's great, because then this kind of problem becomes easier to solve at the database level. But there is another nuance to this. Even if at the database level you know that a particular event is going to update a view, right, or a view of that data, the problem is that the view of the data is not maintained in the database. The view of the data is actually maintained at the application level, because you have to filter it out by the app by the user that is fetching this data, right? So even though the cache invalidation problem is possible to solve well at the database level, when you try to cache at the application level, cache invalidation becomes even harder, because the plumbing and the information is hard. Um, so that's kind of the scope of how what the problems are around invalidating caches. The good news, though, is that Hasura has again all of this information, which is that Hasura knows who's accessing data. Hasura knows who is trying to write to that data, because mutations and actions also go through Hasura. And because of that, Hasura has enough information to invalidate the cache as well. We haven't solved this problem yet. So right now, if you go to Hasura Cloud and you try out caching, you will see the number one style solution, which is not bad. It will get you started. It's a nice way of it's based on staleness. So if you know that your app can tolerate stale data for a minute, especially if you're loading like commonly accessed data, that's great. That will work absolutely fine. And eventually, though, we will enter and start solving the problem, the cache cache invalidation problem as well, right? Which is a significant amount of engineering effort, but it's possible because we have all the information in one place, which is key to solving this problem. All right, folks, let me just check. I think my audio is a little bit noisy, and let me just try to fix my audio. Just
A lot of back and forth noise. It's like the connection is just don't move, just be still. If you're still, it doesn't make a noise. Yeah.
Got it. Got it. Thanks. Right. I've done something, folks. Let's hope that it's a little bit better. So, okay. So
there's just a lot of scratching noises.
Is this noisy as well?
No.
Okay. Cool. Let me try to switch my mic, folks. Just give me a second. Is this better, folks? All right. All right. Cool. Let's see. Sorry for the audio issues. So much for my fancy mic setup. But coming back to this, which was an important announcement for me to make, which is that Hasura Cloud, our aim with Hasura Cloud is to offer a completely automated caching experience at the edge for dynamic user application data, right? Not just dynamic data, but dynamic user application data, right? And to us, this is solving the problem of basically like a CDN, but for dynamic data, right? And this is tremendously exciting. And we've made our first step, which will go a long way for a lot of applications, and we'll keep improving on this over the next few months and years. Next, I would like to talk a little bit about tracing. So, tracing, Hasura and any GraphQL server that you have, right? Whether it's Hasura or not, it's probably going to be talking to several other services. For example, you have you might be talking to a database, you might be talking to microservices, you might be talking to a SaaS service, right? You might be talking to an event system, and you will probably do that. And well, Hasura does that as well, right? Hasura is kind of like this data access and event access orchestration mechanism across your different services. And when you kind of go into production with a microservices setup, inevitably strange things are going to happen, right? And those strange things, you kind of need to know, what is happening, where is it happening, what is, wherever the problem seems to be, what is it saying, right? And so it's inconvenient. And because this has been inconvenient for a while, there have been several developments that have kind of made this easier. And one of those biggest developments is distributed tracing and the rise of a distributed tracing standard specification called open tracing. So what Hasura does is, if you think, I mean, I'll describe how Hasura's tracing works in a bit, but let's take an example of a mutation that's hitting a lot of different services. For those of you who were in the workshop last week, right? We looked at creating this kind of GraphQL mutation that is hitting many different services. You make the GraphQL mutation to Hasura to place an order. Hasura validates that GraphQL mutation, makes sure that everything's correct, and then sends that, delegates that to a REST API, which is your action. Your action itself may talk to Hasura again to do something. Your action itself might do something else to another service, right? It might place in the example that we did last week, we looked at an example where the action goes and updates a logistics or a shipping service, right? And then the action returns an order ID. And what Hasura can do is enrich that order ID and connect it back to the order object, which is there in your graph, right? So many things are happening in order to make this easy and fast. But if you think about it, that basically means that there's quite a bit that can go wrong, right? Especially in production. And so what Hasura does is, what Hasura Cloud does is basically instruments everything with open tracing, so that every single thing that goes through Hasura is it complies to the open tracing spec. And let's say you make a mutation. So let's say the place order mutation, that blue thing that you see on top, that's kind of the top level span. This kind of diagram that we're looking at, this kind of breakup bar chart thingy, that's called a trace, right? And every trace is composed of spans. So we have a top level, and so we have a top level span, And the top level span is composed of smaller spans, right? So the first piece of it is Hasura, which is processing the GraphQL query. The next piece of it is the action. And the third piece of it is Hasura, again, enriching the result of the action and serving that back. The action itself can have subspans within it, which is the amount of time that is spent in the action code, it calling back to Hasura mutations, and that action itself might be calling to a different service, right? All of those traces will show up here, right? The nice thing is that Hasura forwards and instruments all of these trace IDs and span IDs according to an open specification so that you can start integrating this with the rest of your distributed system, especially inside a larger kind of, in a larger application, right? And that's good news because then that means that your services can just include an open tracing SDK and everything kind of works. Today, we support Datadog as a target where these traces can be collected. So Hasura Cloud will emit traces, and Hasura Cloud will send those traces to Datadog. If you have your own services, like your own actions, wherever you've hosted them, your own services, your own, even the database itself, you can connect that to Datadog as well, right? And then you can look at your Datadog dashboard, which will have a centralized view of everything that's happening, right? How much time is spent where, what's going wrong. In fact, I think Datadog has this cool feature which also lets you click on a particular span and you can see the logs of that service, right? Which is, again, also very, very useful. And so this instrumentation is kind of built in. For those of you who are familiar with open tracing, you'll realize that that open tracing is a little bit painful because open tracing is a slightly vague specification. And so different services that integrate with open tracing, like Datadog, have a slightly different variation of the way they interpret traces and spans. And so as and when you try this out, please get in touch with us. And we'll be building more and more integrations to things like New Relic or Azure Insights Monitor or X-Ray on AWS and whatever, right? Cool. The next thing and the last piece that I'd quickly like to talk about is rate limiting. Hasura Cloud has built-in support for rate limiting. Rate limiting is a little bit painful because it requires various instances of the server to talk to each other, right? You need to maintain state across instances, which is not something that's kind of easy to do in a stateless application server, right? You need to kind of maintain a counter, and you need to sync that counter across the number of instances that you have to basically calculate your rate limit value, right? And Hasura Cloud kind of has a little bit of state that it maintains at the edge, which can take care of making sure that this counter is maintained. Hasura's rate limiting is fairly straightforward. It basically works, it's parameterized by the end user. So if it's unauthenticated, then by IP or by session variables. And you can rate limit based on number of requests per minute or query depth. Rate limit is, the rate limiting feature is kind of more of a security and a quality of service feature rather than an API metering feature. And we can talk about that later. But that's kind of what you'll see right now. Hasura Cloud will also eventually have a cost wallet-based rate limiting, which is kind of more a dynamic, which is like a more dynamic version of rate limiting, where we'll be able to look at the cost of a query, and then depending on the overall cost that we have across systems, we may or may not decide to fulfill that query, which sounds nice, but sometimes the ROI on that can be low because you want to have a predictable API, not an unpredictable API, right? Like this API worked at 9 a.m., but then it stopped working at 2 p.m. So there are challenges with doing that, but that is something that we're working on as well. The last piece that I will talk about before I end this is query capture. Hasura Cloud captures API calls. It can strip query variables and session variables, and then you can export those captured queries over a time window. These exported queries are very, very useful so that you can kind of do regression testing with them automatically, right? You can use the Hasura console to run those tests, but you can also pull them into Postman. You can also pull them wherever else you want. And also for some use cases around making it easier to manage allow lists, where you capture queries in staging and then use them for production. But query capture is kind of the underlying feature that makes this possible to do. All right. So with all of that said, what I basically wanted to announce was that Hasura Cloud takes us one step closer to our dream of GraphQL basically becoming this invisible, beautiful part of your infrastructure, where you continue to do the work that you love, you continue to use the tools that you love, your whatever framework, whatever language, and as the world changes around us, as the front-end world changes around us, as the back-end world changes around us, GraphQL can still remain a very useful and loved part of your infrastructure for your API consumers, whether they're building apps or whether they're consuming APIs. So check out Hasura Cloud. I think the URL should be live now. I might have made this announcement a little bit sooner than the website went live, but check it out. And it's in public beta, so you might notice a few rough edges. Please get in touch with us if you have any issues, and we'll make sure that we fix it so that it works in the environments and with your workflow. And I didn't have too much time to talk about the security piece and how we ensure network security, but there is a blog post that has some details around IP whitelisting, VPC peering, private links, and stuff like that that are also important in certain kinds of environments. But if you're using Heroku, it should be super easy to get running with Hasura.io/cloud. That is it for me. Thank you so much, and see you online on Hasura Cloud. Back to you, Rarushi.